6.1. Solve linear systems by graphing. System of linear equations, or in other words, linear system, involves two or more linear equations in the same variables. So for example, you can have x plus 2y equal to 7 with 3x minus 2y equal to 5. And the solution of a system of linear equations would have a coordinate x, y that satisfies each equation in the system. Note, a linear system that has exactly one solution is called a consistent independent system, because the lines are distinct and intersect. And there are different methods of solving a system of linear equations, and I'm going to show you the graph and check method first. For the graph and check method, you first graph both equations. You can either use the slope-intercept form or find the x-intercept and the y-intercept. And then you need to identify the coordinates of the point of intersection, and then check the coordinates algebraically by substituting into each equation of the original linear system. Part A, guided practice. Tell whether the ordered pair is a solution of the linear system. So I need to take this ordered pair and substitute it into each of these linear equations. Half times 4 minus 3/4 times -2. And we need to determine whether it equals 7/2. So I'm going to go ahead and simplify half and 4, and that makes 2. And this makes positive 3/2. I can change this to 4/2. And this will make 7/2. So it does equal to 7/2. Okay, now we can check the other equation. 4 times 4 plus 3/8 times -2. Okay, you can simplify the 2. You get 16. You got a negative sign here, so there'll be -3/4. I could change 16 to 64/4 minus 3/4. And this would be 61/4. And yes, it does equal 61/4. So 4 -2 is a solution. Part B. Solve the linear system by graphing and then check your solution. For this linear system, I'm going to use the x and y intercepts to graph each of these linear equations because they are all in standard form. So for this first equation, to find the x-intercept, I'm going to take -22 and put it over -5. And this will give me the x-intercept. And in decimal form, it will be 4.4. I'm going to change it to decimal form because it will be easier to graph later. So I'm going to write the coordinates. And for the y-intercept, I would take -22 and put it over +8. And this will give me negative 11 over 4. And I'm also going to change this to decimal form, negative 2.75. And my other point will be, or my y-intercept will be 0, negative 2.75. And for this other equation, the x-intercept will be negative 9 over negative 2. So I simply took this number and I divided it by the coefficient of x. And this would be 4.5. So I'm going to write the coordinate 4.50. And for the y-intercept, it will be negative 9 divided by the coefficient of positive 3. This will be negative 3. 0, negative 3. Okay, I'm going to go ahead and graph both equations. I'm going to begin with 4.40, about here. And then 0, negative 2.75. And then this equation, 4.50, should be about here. And 0, negative 3. And we can go ahead and graph. Okay, I'm going to first graph the first equation. And then the second one. And it seems like the intersecting point is at 6, 1. But we need to check. So I'm going to take the first equation, negative 5. I'm going to substitute 6 in for x plus 8 times 1. And we have to find out if it equals negative 22. Negative 30 plus 8 equals negative 22. And then negative 30 plus 8 is negative 22. So check. And for the other one, the equation is 3y, so 3 times 1 minus 2 times x is 6. We have to find out if that equals negative 9. 3 minus 12, and yes it does. Check. Okay, for this next example, I'm going to first clear the denominator by multiplying by 4. So 4 times 3/4 x is 3x, plus 4 times 1/4 y is y, and then 4 times 13 over 2 would give you 26. And now I need to find the x and y intercepts. So I'm going to first look for the y-intercept, which is just easier. I can just let x equal to 0 and y would be 26. And for the x-intercept, if I let y equal to 0, then x would be 26 over 3. Or simply 26 divided by the coefficient of x. And then I can rewrite 26 over 3 as 8 2/3. And for the other equation, I'm also going to multiply by 4 because I want to clear the denominators. 4x minus 3y equal 26 as well. And then I can find my x and y intercepts. So for my x-intercept, I can take 26 and divide by 4. Remember, you need to use the coefficient of x to find the x-intercept. And then this would be 13 over 2 and 6 and a half. And for the y-intercept, I'm going to take 26 again and put it over the coefficient of y. So it's the same thing as letting x equal to 0, and then you'll be solving for y. And this would be equal to -8 and 2/3. So I'm going to write my coordinate points. 6.5, 0, 0, -8, and 2/3. Okay, now we need to graph these equations. So I rewrote the coordinate points here for the first equation, and I'm going to graph that using red. So I changed the increments, so please change it as well. 0, 26, 8 and 2/3. It's about here. So I'm going to connect the lines. And for my other point will be 6.5, 0. And -8 and 2/3. So we can estimate it to be around here. So your intersection point is at 8, and I'm gonna make a guess that this is about 2, but we need to check. So the intersecting point should be 8, 2. And now I'm going to check if 8, 2 is a solution of this linear system. So 3/4 times 8 plus 1/4 times 2. I'm going to recopy the other side. Simplify. 6 half. So this could be rewritten as 12 over 2. And it does equal. Yay. And then the other one, 8 minus 3/4, 2. And yes, so since 8, 2 satisfies both equations, this will be the solution of the linear system. And this will be the check. Word problem. With a minimum purchase of $25, you can open a credit account with a clothing store. The store is offering either $25 or 20% off of your purchase if you open a credit account. You decide to open a credit account. Should you choose a $25 off or 20% off of your purchase? Please explain. Now we're going to use the systems to solve. So we need to set up two equations. but first we need to define our variables. X will be the purchase amount, and Y will be the amount you pay after the discount. Okay, so your first equation will represent the $25 off. So I would take the paid amount, Y, and set it equal to the purchase amount minus 25. And the other one would be, again, Y equal to 0.80 times the purchase amount. So Y would be the amount that you are going to pay after the discount. Now, to find the intersecting point, we need to set these equations equal to each other. So x minus 25 would equal to 0.80x. And then I can take x and subtract 0.80x and set it equal to 25. And this would make 0.20x equal to 25. And x would equal to 125. And then I can take one of these equations, either one, I'm going to use this one, to find my value for y. So 125 minus 25 would equal to 100. So the intersection point for both of these equations will be at 125, 100. Now, I'm going to use a graph to show you when is it worth it to take a $25 off and when is it worth it to take a 20% off. Okay, so first I'm going to graph y equals x minus 25. Well, because the y-intercept is a negative number, I need to start at this point. But I'm going to first begin with a dotted line because we don't need anything below the x-axis. And I'm going to begin my solid line. Okay. Now I need to graph the other one. Y equal 0.80x. Okay, so this must go through the origin as well as the intersecting point that I calculated earlier. So I must draw a line through these 2 points. So if your purchase item is below $125, if you take the $25 off, you will pay $25, for example. But if you take the 20% off, you will pay $40. So you're better off with using the $25 discount. Okay, so we can conclude purchases below 125 use $25 off. And for the other case, if your purchases are above 125, if you use a $25 off coupon, you would have to pay $125. If you use a 20% discount, you only pay $120, which is $5 less, which is better. So for purchases above $125, using the 20% off will be better. So according to the graph, we want the amounts that are below the red line and then after $125, the amounts below the blue line for the purchase amount. And this concludes the lesson.